Thanks very much. So good afternoon, everybody, and thank you ever so much, Nikita, for inviting me to speak. So as kind of referenced in the bio, I've been researching in the areas of digital note-taking for the best part of a decade, which is still a little bit scary. And it's really fantastic to be able to share some of my research with you, particularly in reference to educating our young undergraduate scientific community. So just to give you a bit of a brief outline of the presentation to come, I'm going to kick off by giving you a bit of background about me. I'm going to tell you about the PSDI project, which is what I work on currently and where a lot of this research is kind of coming into the fore now, and also to explain how I ended up in this field of research in the first place. Then we're going to talk through some of the different aspects of the research, so talk about scientific record keeping and electronic lab notebooks, and particularly thinking about their use in teaching labs. I'm going to give you some examples of actual successful digital transformations I've seen across both an undergraduate lab and at A-level in school, and then talk about the Skills for Scientists program that we run. So again, thinking about that more educational side of things, and then finish up with some general thoughts for the future. So about me, I think this has mostly been covered by Nikita's bio, but this read about me, thank you very much. But yes, I'm a Senior Enterprise Fellow at the University of Southampton, and a lot of my work is centred around process recording, so looking at digital note-taking, electronic lab notebooks, and digital tools in the labs, and FAIR data, metadata, all the things I'm going to be chatting about in this talk. And I just wanted to tell you a bit about PSDI, as this is the initiative that's really enabled me to continue my research in all of these areas, and it provides a platform for me to use it to influence the tools, guidance, and services that we're going to make available for our community. So PSDI stands for the Physical Sciences Data Infrastructure. It's an EPSRC funded project between the University of Southampton and the Sciences and Technologies Facilities Council. And we are ultimately aiming to create an integrated data infrastructure for our physical sciences community. We want to be able to provide them with access to highly curated data sets, guidance on the best tools to use, exemplars on how to share your data and create metadata, and a range of different tools and services to use on their data. And we're kind of targeting all the way from, well, we're actually doing some work with schools, all the way through undergraduate, postgrad researchers, kind of like all the way through the different career stages, if you will. So how does this all fit in? How did I end up here? Well, I did my undergraduate in computer science at the University of Southampton, which I absolutely loved. And I knew early on that I wanted to do a PhD, but I really wanted to find an area that I could apply my technical skills to in another domain. So I ended up doing an iPhD in web science, which was a really big eye-opener because they introduced the notion of the web, and indeed many other aspects of technology, as a socio-technical phenomena, whereby the people are just as important as the technology, and we help to shape the direction of the technology. So when I was first looking at potential topics for my PhD, the notion of digitizing scientific research came up quite quickly. And as a computer scientist, I have to say, I was completely baffled that so much work was still being done on paper. It seemed really alien to me, as whilst admittedly I still scroll in a paper notebook sometimes, and I do very much understand the affordances of paper for quick and easy notes. I've always stood by the notion that anything on paper should exist electronically, so that if I forget it, lose it, or more likely spill tea all over it, then none of the information is actually lost. So I decided to embark on what I didn't know at the time, but would actually form an epic 10-year journey that is still very much going on to investigate the digitization of scientific research. So I'm aware that this is quite a short presentation, so I'm not going to go into the slide in great detail, but I just wanted to note that the research presented in this presentation has involved many years of a range of different types of work, including extensive literature investigations, software investigations and evaluations, qualitative research in the form of surveys, focus groups, and ethnographic observations, and also a range of technical prototyping. And again, very important to notice, we are looking at very much the people and the social aspects of this just as much as the technology. So let's get to it. Scientific record keeping is an age-old concept where scientists will write down notes and records about their work. Interestingly, I recently presented at the Royal Society of Chemistry Historical Society last month on chemists' notebooks. And there were presentations on early scientist notebooks dating back centuries, showing some of the very early notebooks and even the very early concepts of actually taking multiple pages and finding ways to bind them together to form a set of notes, those very early paper lab notebooks, if you will. And I always think that the paper notebooks is a very interesting concept because let's think about if we consider a time traveler from the past landing in today's world. There are a lot of cool futuristic things that they would see. So, people with tiny computers in their pockets, people with well-hidden AirPods, seemingly, speaking into the ether as they're covered by long hair, smart devices that you can control with speech. And, we even kind of have hoverboards now. So Back to the Future wasn't that out there. But if the time traveler landed in certain labs, say labs using paper lab notebooks, which is unfortunately still quite prevalent, especially in academia, they could probably be forgiven for thinking that perhaps the time they'd landed in wasn't 2024. And the use of paper isn't entirely unreasonable. It does still have many advantages. It's very cheap. You can wander around with it and not need to be near a plug or a router for internet connections. You can write whatever you want, wherever you want, so kind of all over the page, world's your oyster. And whilst arguably you could, of course, still ruin it with a cup of tea if you're as clumsy as I am, you wouldn't need to remortgage your house to procure a new piece of paper, much less if you did that to an iPad. However, it's a lot less flexible in the ways that really matter today. It's much harder to back up. And my extensive research across all the different undergraduate and postgrad community has also demonstrated that, unfortunately, people put a lot less effort into backing up paper-based data. So, it's a lot more likely to end up getting lost, because whilst people might take their electronic data and go, oh, I've got to have this on a memory stick, a hard drive, the university servers, no one actually thinks that way about their lab book, unfortunately. I did have quite a funny story where I asked a bunch of PhD students in one of my focus groups, how do you back up your work? And, again, I got all the long litany of answers for the electronic stuff. And when I asked about their paper lab notebooks, one of them said, I don't. Another one said, oh, I have those carbon copy pages that it automatically creates me a copy. I was like, oh, that's nice. So where are they? Oh, they're still in the lab. So again, ultimately in a situation where should something bad happen to the lab book, those copies are still in there. And again, this is actually a lot harder to share and to search. So if you go home, you leave your lab book in the office and then get home and you need it, it's going to be a lot more effort to retrieve it than if you've actually got electronic cloud-based versions of that data. And as I kind of just alluded to, we need to be really aware that there are much more serious consequences of only using paper. Now, I'm aware that these webinars are more geared towards undergraduates and postgrads, but I think this point is still very relevant because ultimately our postgraduate community will be made up of a subset of our undergraduate community. And what we teach them at undergraduate level will impact how they undertake their future research. So something that's also always worth considering is what would happen if your lab spontaneously set on fire and you lost everything in it? Now, this may be a really extreme example, but unfortunately, it's actually based on real events. Before my time at the University of Southampton, one of our labs did indeed burn down, and some PhD students lost everything. Now, I know it's obviously not quite that simple as a lab burning down, because obviously that means, loss of resources, instruments. In certain subjects, people lost specific samples. So, it wasn't just the paper notes that went missing. But ultimately, if your lab does burn down or something else terrible happens and all of your research is stored on paper in the lab, you're up the creek without a paddle. And I would argue it's incredibly important that we distill these lessons to our undergrads and we teach them how to record their work digitally and we get them comfortable with the use of digital tools so that when they progress further in their career, they don't run the risk of this happening. So for this reason, and many others, the concept of the electronic lab notebook was born. So it was originally created to serve as a very direct replacement for the paper lab notebook, or at least that's very much how it was kind of billed in the early research papers and some of the early, advertisements of why one would want to use such a thing. And it was created to ensure the digital capture and retention of the scientific record. And I must confess, in my young naivety, when I first heard about the concept of electronic lab notebooks, I just assumed they'd be the answer to all of our problems. And I thought it'd be a really simple matter of, what's out there, identify the key player, and just be like, well, I guess everyone should use that then. Simples, right? Well, unfortunately, as I was about to find out, and why I'm still researching this area 10 years later, is this is no simple matter. As it turns out, there are a lot of barriers to electronic lab notebooks. So firstly, they require a huge investment, both in terms of time and money. So many of them have license fees, but then even aside from that, you need to think about the hardware setup in your lab. So I think I heard someone from the previous presentation say, we don't even have screens in our labs. Well, unfortunately, screens or devices of some sort are actually needed to make this work. And not all students can afford their own devices. And even if they can, there's no reason they should have to risk contaminating them in the lab. And they certainly probably can't afford or have use for, say, 2 devices. So then you need to think, okay, well, if we want our students to use digital tools in the lab and therefore digital hardware, do we need to supply the lab hardware, which of course then costs money. You've also got the fact that people are often really reluctant to make changes if they have established practices. And these changes can also be really disruptive if they occur mid-degree. So, it can take time to train people to use these systems, and you can't just expect people to adapt overnight. So if you've come in and done your first and second year in a certain way, you might not be that keen to change things for your third year. And there's also, and again, slight of a less issue for undergrads, but still worth considering and an important issue for the future, is there are a lot of potential issues when it comes to exporting data out of electronic lab notebooks. So many industry electronic lab notebooks lock the data away in proprietary formats, which makes it really hard to export in general if you want to share it, but also even if you just want to take it out and put it in a report. And you might be thinking, why does this matter? Surely our students can just use these tools and potentially, copy over the bits of data as needed, and it's all fine. But it's not that, again, it's not that simple. The big overarching reason that electronic lab notebooks are important to scientists is that we need to accurately record our processes so that our work can be replicated. Now, I appreciate for undergraduate labs, this is perhaps a secondary concern, as obviously the main goal is about teaching and learning. But I would put to you that, as I said previously, the entirety of our postgrad community and a decent chunk of our research community as a whole is made up of a subset of our undergrad community. And we need to instill these good habits from the beginning. And we need to teach them how to actually properly record their research using digital tools, because then we're upskilling them to be able to produce work that somebody else might actually be able to reproduce, and familiarise them with digital tools along the way, which is going to be really useful irrespective of what direction they take their career in. So what is our current state of play here? Well, this graph depicts the results from a recent survey about our community's uses of ELNs. Now, obviously, this does represent the people that were actually willing to fill out a survey. So it doesn't necessarily represent the whole community, but from our sort of outside knowledge and people we've spoken to and general previous research, I would say this is a pretty accurate view. Now, it may seem depressing that about 50% of the respondents aren't using electronic lab notebooks, but this does mean that at least 50% are using something, whether that's generic or otherwise. So I spent a lot of time talking to people from different universities, and of course, I know firsthand what's going on at Southampton. And even though it's slow, I will say I've noticed, certainly in the universities I'm speaking to and the places I'm going into, a noticeable shift in implementing digital tools in laboratories, particularly actually in the undergrad teaching laboratories. So I'd like to give you 2 examples of successful implementations that I've seen and why I think they've actually worked. So the first example is from the University of Nottingham. So they've actually implemented, this is the project I'm on the advisory board for, but they've actually implemented electronic lab notebooks in both their undergraduate and postgraduate labs. So for their undergraduate labs, they had OneNote implemented across their entire labs. They went paperless. And then they actually started to introduce their specific electronic lab notebook for synthetic chemistry called AI for Green in one of their teaching labs, which has also been implemented in their postgrad labs. So the way they've done their implementation has subverted quite a lot of the barriers that I mentioned earlier. So for their undergrads, they purchased Microsoft Surface tablets for the lab. So each student has their own hardware to use that they don't have to bring in themselves. And the devices are confined to the lab, which means there's no cross-contamination issue. They also introduced these early in the student's university journey. So they just made it mandatory for new students, but they gave a bit more flexibility to existing students. And they ensured just the simple things like the Wi-Fi in the lab was good enough to handle everybody using it, and that there were enough power supplies to actually charge up the tablets. Sounds really simple, but it can make a huge difference. And not all labs are actually kitted out for that. And in the postgrad labs, they installed desktops, so one per fume hood, and they provided a hardwired internet connection. So immediately they've subverted all of those hardware barriers. Admittedly, I know that costs money, but they've made that investment. And they also, interestingly, had quite specific different implementations for students versus postgrads, because again, they've kind of taken on board that actually, and I'll sort of touch on this later, but what you would need to think about for teaching students with an electronic lab notebook versus what you would think about in terms of offering services to a postgraduate researcher aren't always the same thing. The second example is actually from a school. So I'm going to caveat that this is a private school with the money to achieve this, but they've actually managed to make all of their science labs paperless, which is something cool to aspire to. So on the year they decided to go paperless, they required all new students to come in with Microsoft Surfaces. And after a few years, that obviously then filtered through and you ended up with all of the students having the relevant devices. But again, they revamped their labs to ensure that the lecture rows and the lab benches have power supplies. They use OneNote because people are familiar with that. The school already pays for it. And again, much like with Nottingham, they used OneNote. The university already pays for that. We definitely should be thinking about making use of some of those tools that we already have access to, particularly if it's hard to pick more specific tools. But they use like the class notebook aspect of OneNote, so the teacher can see all of their work and they all have their own different sections in the notebook. They also typically generally still required to use the stylus unless they have a laptop dispensation. So again, they're kind of physically writing and still learning through that. So I could go into these for hours in terms of the different things I've learned, but I'm aware we're running low on time, so I'll try and speed up. But I just think we need to be really mindful that different situations call for different types of tools and different requirements. So, it's really important that our undergrads are skilled in how to use these tools, and they need to understand how to use them and how to use them effectively. They need to learn how to record not just their data, but their observations and the all-important contextual information that so often gets lost or left out. But we also need to remember that our undergraduate labs are for learning, and we need to make sure that the tools we use also provide the best mechanism for that. So, for example, a key benefit of certain electron lab notebooks for postgrads are things like automatically pulling in health and safety data, automatically calculating things like molecular weights. And, that's a great time save for somebody who's, later on in their research. But we don't actually necessarily want to automate these things for our undergrads because we want them to learn and we want them to be able to go into whatever their next career journey is well-rounded with these skills. So just a quick nod to the Skills for Scientists course that we run. So we run this at Southampton for our interns and we'll be putting it wider next year. But these are kind of some of the things we've identified that don't necessarily get taught across the science degrees, but we think are really, really important if you want to work particularly in the kind of digital science sphere, but also general things about research data management, FAIR data, actual note-taking and recording your note practices, very important. And just to finish quickly, as I know I'm running out of time, some thoughts for the future. In order to transform our labs, we need the key people at the top to get on board, and we really need investment. You can't just magically decide to implement a new system. Labs need to be properly organized to implement these tools, and it's really worth thinking about the appropriate software. So potentially for undergrads, things like OneNote or the whole Microsoft ecosystem might be more useful. And the university pays for them, and then you might want to think about specific electron lab notebooks for postgrads. And then I'm sure Nikita will be sharing these slides, but these are just relevant talks and publications and acknowledgements. And I'm happy to answer any questions.